So in the previous session, we have understood different outputs for different topology of the neural networks. So now that we have understood the topology, different types of inputs to the neural network, and different types of output to the neural output from the neural network, so it's time to make some basic assumptions which make our study of neural network structure or basics for making the building of a neural structure more easy and more simplified. So we have certain assumptions made, and these assumptions holds good for most of the neural network architecture which we build or which we have today. But there are certain violations as well. But since these are the assumptions, it is for on a whole or a large number of neural networks which we have today. So let's just jump into the assumptions of the neural network. So the very first assumption would be this is a neural network. So this is how a neural network actually looks like. Uh, so every neural network, say any complex neural network, we can have the neurons in arranged in layers. So each one of the box or the red box which you are saying is called as layer, and each layer consists of any number of neurons. So currently I have taken only 3 neurons to represent it very simplified in a simplified way. So yeah, the basic assumption would be all the neurons or the all the neural networks will be having a neurons arranged in layers. So here the L1, L2, etc. will be the layers. The very next assumption would be every neural network will have one input layer and one output layer. So all the signals from the external world, all the input signals should enter the neural network through the input layer and exit out through the output layer. So to be more clear, every neural network will have a input and a output layer. All the signal from the external world should enter into the neural network through the input layer and exit out to the through the output layer. So we have other special layers in between these input and output layer, and we can call them as hidden layers. So hidden layers are nothing much more special about other than the input and output, but they are more similar to input and output layers. That is in terms of neurons, etc. Only thing is they are more. They do the a minimum task at a time. See, when it comes to any image processing or any complex task, just an input and output layer would not be sufficient enough to get a more accurate results. So then we introduce a concept of hidden layers in between the input and output layer. So the how many number of hidden layers, how many neurons would be the decision parameters or the hyperparameters which we will be discussing in the further sessions. But as of now, we can assume that in between the input and output layer, we have certain special layers called as hidden layers. Yeah. So the third assumption would be a neuron in a input layer or a neuron in one layer are densely connected with neurons in the next layer or the subsequent layer. In other words, every neuron in a layer 1 L1 will be densely connected with every other neuron in the layer 2. You can clearly see that this particular neuron, the very first neuron, is connected with the every other neuron in the very subsequent layer L2. So it holds good throughout the network structure. Even though we have densely connected neurons, that is a neuron from one layer will be connecting to the every other neuron in the layer 2, we do not have interconnections. That is, the neurons in a particular layer won't interact each other. They interact with the neurons with the subsequent layer, but they themselves don't interact. You can see there is no clear indication, right? We have a connection from this neuron to this neuron, but there are no connection between the neurons in the particular layer within the same layer. Yeah, this is one of the assumptions which we make to make our understanding more simpler. But by these assumptions, we are not declaring that we are exactly following the structure of the human brain. No, the structure of the human brain would be still more complicated, and the working of that neural structure would be more complicated. And we as a human beings we are not still at the understanding to get the overview about the interconnections and about the working or the training of the human neural network. But these are for building the artificial neural network and make our building capabilities more simpler. We are making these assumptions. So we had our third assumption that each and every neuron in one layer will be densely connected with each and every other neuron in the subsequent layer, but there will be no interaction between the neurons of the same layer. This is an assumption. Moving on to the next assumption, that every neuron or every connection between two neurons will be associated with a weight. Okay, so each and every connection has its own weight. The connection from neuron 1 from L1 to the neuron 1 from L2 have a weight W1. Then neuron 1 to neuron 2 will be having another weight W2. Then neuron 1 from neuron 3 would be W3. So each and every interconnection has its own weight associated with it. And each and every neuron within a layer has its own bias. So bias, in other terms, we can call it as a threshold to get activated. So each and every neuron in a particular layer, so this will have certain bias, this will have certain bias, and this will have certain bias. So each and every interconnection has its own weight associated with it, and each and every neuron has its own bias associated with it. Next, we don't have a connection or a communication between the neuron of say L2 with directly or skipping a layer from L3 to L4. So this is what I have tried to represent it over here. There will be a communication between only the next subsequent layer, but there will be no skipping of one layer and communicating with the next one. This is very clear, right? So we have the neuron can communicate with the very subsequent neuron in the next layer, but not with the skipping of that particular layer and connecting with the next neuron in the very next layer. So this is one other clear assumption which we are making. Then the total number of weights in an interconnection, say if we have n1 connections from layer 1 to layer 2, and we have n2 connection from layer 2 to layer 1, then the number of weights we will be ending up with is equals to n1 into n2 into weights, right? Because we have each and every individual weight associated with each and every interconnection, right? So we have how many number of weights we can see in this particular connection? We have 1 2 3 4 5 6 7 8 9. So we have 9 weights associated with this particular interconnection. So this is how we distribute the weights, or we have to calculate the number of weights associated with that. So now that we have completed different types of or different assumptions which we made on the neural network, it's time to have a overview about the discussion which we had again. So yeah, the very first one would be neurons are arranged in layers and layers are arranged sequentially. Yeah, right. They are clearly arranged in a sequential manner. We can see that, yeah, this is a sequence. This is how the signal flows from input to the output. So the signal as well as layers will be arranged in a sequential order. So the very next one was neurons within the same layer do not interact with each other. Yeah, that was the clear assumption, right? Yeah, we can communicate with these two, but there is no communication between the first one of the first layer and the second one of the same first layer. There is no clear communication. There will be no communication between the same neurons of the same layer. Then All the inputs enter the network through input layer and all the output go out of the network through the output layer. Yes, we have also made this assumption. Then neurons in consecutive layers are densely connected. That is, all the neurons in the layer L1 are connected to all the neurons in the layer L plus 1. Then every interconnection in the neural network has a weight associated with it, and every neuron has its own bias associated with it. Then this is one of the final assumption which we can make, that is, all neurons in all the layers use the same activation function. Yeah, this is one of the major assumptions which we can make out here as well. Yeah, that is, the activation function which we use, either it may be a softmax function or a sigmoid function, it holds good or it is applicable to all the neurons in the particular neural network. So we can just say I will apply the softmax function for this neuron, and I will apply sigmoid sigmoid activation function for this neuron. No, we are making an assumption that whatever we use at the start, we have to apply it for throughout the network, right? So this is one of the final assumptions which we are making for making our understanding of the neural network more simpler and more understandable when we approach building it.